we have the same exponent with different bases. So how do we combine that to make it more simple, right? So how do we simplify something like we have a to the power of m times b to the power of m. So they have the same exponent of m, but we have different bases. Previously, I said that, for example, if I had x times x, it would be x squared, right? Because you're adding the exponents together, right? But this only works if they have the same base. If you had x and y, right, you can only write it as xy, right? You couldn't change the exponents, really. But here, right, they have the same exponent, right? But they're different variables. And I'm going to show you what to do with this in a minute that you could technically also do with this, but like nobody ever like writes it all out because it's like, what's the point, right? So when they have the same exponent but different bases, you would just the way you can see it as is a times b, so ab, put that all in parentheses to the power of m. So I didn't change the exponent. The exponent stays the same m. I'm just multiplying these two bases. And that's technically what I'm doing over here, right? I am just taking the bases, right? They're different bases. This is x and this is a y, but they have the same exponent of 1. So I could just write it like this, right? X times y to the power of 1, but that's just xy, right? So there's no real point in doing the parentheses, exponent of 1 for this. You kind of just leave it like that. But this is a whole concept of, this is how you can see it more clearly. So an a is different from a b, but they have the same exponent. So we just multiply the bases and keep the exponent. So if I had, let's say, 5 squared times, I don't know, 3 squared, I would just multiply the bases. So I get a 15 and keep the exponent the same. Now I can work it all out if you want me to. So 5 to the power of 2 is 25, right? 3 to the power of 2 is 9. Okay. If I multiply these out, I'll get 25 times 9 will give me 45. That'll be a 5 right there, a 4 right here. 18, 22. So this could be 225, right? And now I'm going to do this one over here. So it'd be 15 times 15. This is a 5, 2, a 5, 7, 0, 5, 1. Add it all up together, we're going to get 5. 7 plus 5 is 12. 1 plus 1 is that. So this is equal to 225. Right, that's the same answer right here. So it does work. Here's the proof of that. Not the most probably most professional proof, but this is just an example, right, of why this formula works for this, right? So a quick recap: when we have different bases, right, but we have the same exponent for both those bases, we can just multiply the bases, right, a, b, and then just keep the same exponent that they both have right there, and multiply them, and then take that all to the whatever the same exponent they had. Right? So that's how that works. That's how you would simplify something like this to get this, right? That's about it.